Hi everybody. Today we're going to talk about how to decrypt and extract the strings from Qbot malware in an automated fashion. I'm going to provide a Ghidra script that will go through and decrypt all the strings and then put comments at their location of usage in your database so that you can look for indicators, you can determine general functionality, and can really help you zero in on location or interest. So Qbot uses a ton of strings and they're all encrypted in a big configuration block. Each decryption function will basically pass an argument that will have the index in the configuration block, and then it'll do a simple XOR decryption. But because of the large volume of strings, if you don't decrypt them, it's really hard to understand what the malware is doing. And by decrypting all the strings, you can get a general sense of the capabilities. You can use them as indicators to zero in on location of interest. It can really help speed up your analysis. The file we're using today, I'm going to show the script, demonstrate how the script works on two files. The first file is the unpacked Qbot loader malware we did in the previous videos. And then I'm also going to do an unpacked file for a newer variation of Qbot that's come out more recently. So the script itself is going to be my GitHub page. It's listed in the video description, so you can download it to use on your own. And the hashes are both also in the video description, so you can download and practice. I'm only providing one script that's going to be for our first sample, but we're going to demonstrate how to modify the script just by changing a couple variables so that it'll work with most Qbot variations. The important thing is the script is relatively generic. It just has a configuration block that you need to input a few variables like the key address, the target crypto function, and then it will run through and perform the operations on any Qbot malware. So to start off, we're just going to demonstrate how the script works. You'll see it in practice, and then I'll go through and show you how to find the key variables and how to update it for the different versions of Qbot. So to begin with, we need to run the script. So I'm going to go up to the play button. Actually, let me see. I forgot to turn the highlighting on. So let me go ahead and do that real quick. Alright, be a little bit easier to follow the mouse this way. Alright, so we're going to work on this first sample, the F5FF sample. And then I'm going to hit the play button to run our script. And I already have my scripts loaded. So it's in the AGDC services. And this one is the F5FF 6 delta hash string decryption. So all I do is select it, hit the play button to run it. And then I can close down the script file. So you can see now if we look at this console window, it has at the bottom maybe 10 addresses it couldn't resolve the parameters for. And then above that, we see all the decrypted strings with the associated index. So you can see at index 3409 is the string create service W. At index of the configuration box, hex32 fox7 is image/gif. So this way, on anything that didn't resolve, we can manually determine the index, and then we can look it up in this output, and then just update the comment manually. So let's look at one or two of these ones that couldn't be resolved, so we can see it. So hit G to go, and I'll go to 406688. And we can see here the parameter in this case is passed by through the register. It can either be passed as a function argument by push on the stack or through a register. In this case, this can be param1, and that's why the script couldn't identify it because it didn't know what the index is. Let's check one of the other ones. So 405 alpha alpha 4. And we see the same thing here. We see an ESI +4, so it's not an immediate value that we can look for. And so that's why, if we want to manually determine it, we'd have to trace back these variables and identify what the index is, and then we could go up to this function, or this decrypted configuration block, find the appropriate index, and then we could comment the function on our own. So in fact, let's see what the script looks like too, though. So we can see our target function. Let's just go ahead and copy this. Hit G to go. And then we'll go to one of the cross-references just by double-clicking. So you can see at all the cross-references, you can see this offset is 2F8 delta. So we'll go ahead and look in this configuration block just to verify. So we'll go to 2F 8 delta, and we see it says command exe, string, and we see that puts to the comment right here. And so that's what basically the script does. So we go into it, so we look at a different one, and we see, alright, so that was the wrong function. Alt left to get back. So I'm going to go to a different cross-reference, and we see this one is a .dat, section and so forth. So now that we see how the script works, let's go show you how to set up the script itself. So you can see the top of the script, we have to declare our variable. So we're going to have two sections to declare, one where the argument is pushed by the stack, and one where the argument is passed via register. It won't be guaranteed to have both of them, but all the samples I've seen have both of them, and sometimes I'll actually have more than one, as we'll see in the second example. So in this sample, you can see our key, our ciphertext, and our ciphertext length are the same in both crypto functions, but that doesn't have to be the same. They can actually be different keys and different ciphertext blocks for the different decryption functions. And while I only have one function, for instance, that pushes on the stack, and one to push it on register, the newer variations, you can actually have multiple functions that will have different variables for the argument push on the stack or the register. In this case, you basically just run it more than once by updating it. So instead of making it too generic where you can take any number of functions for each of these methods, I put one for the stack and one for the register. And then if there's more than one for that situation, you'll basically just run it once, make a copy, and then update the copy and run it again. So it's pretty simple to handle and just easier to code that way. So our big thing we need to know is how to find the target function, and then how to find the registers or the variables for the key and the ciphertext. EA here is for effective address, basically just a key address, ciphertext address, and ciphertext length. Let's start with finding the target function. If we look back at these decrypted strings, you can see it's generally a relatively large cipher block, configuration block, and because these are indexed to the strings, they're often at kind of odd numbers, so they're not at even numbers. So 2F19, 2F7 delta, 2F8 delta. It's not at 2800, 2810, and so forth. There's no padding in it. So we're going to use that fact to our advantage in order to quickly find this crypto function. So first, we're going to do a search. I'm going to do Control-Shift-E, and we are going to search we'll do it first for the push. We're going to do push space star 0x1. And I'm going to look in the instruction mnemonics and operands, and I'll hit the search all. Now, the reason I'm searching for the push of hex 1 instead of just push hex is if I just do push hex, it's going to bring me more than 500 results, and then I'll get too many false positives to look through. And so by narrowing this down to just one number, I'll look through the ones first. If I don't find a good number, I'll look through the twos and so on. All I'm doing is I'm going to scroll through here and look for a large hex value that looks like an odd number, not used for something else. You don't want to see it repeated like these 10s are used multiple times. The string decryption is probably only used once per index, maybe twice, and so that will help you find it too. So 103 could be an option, so we can select that, but we see this is pushed as the argument for the get module handle, so that one's not the case. 104 is repeated too much. This 1122 is an option, so we click that, but again, that's pushed as multiple arguments into this global variable, the D word, so that doesn't look like it. So we keep scrolling through, just looking for large odd numbers. So here's two that look great. 18 echo 1, 18 F9. Those are unusual numbers. Let's click the first one. And we can see this first one is indeed to our crypto function, because our function already put the comment. And let's check the other one too. And the same way, this is 18 F9, has the software Microsoft near the registry path. So both of those work. So we know our function is 406523. So let's go ahead and we can see that's what we have here, 406523. Now, obviously, you're not going to know this because you won't be able to run the script the first time. So let's go ahead and just label this as a crypto decrypt strings. And we want to see how we can identify it. So we go into it, and I'm going to open up the graph view. And what we're looking for is basically just an XOR crypto function. So we can see here we have an XOR inside of a loop. And then we scroll through and we see another XOR inside of a loop down here. This is why I already run my coloring scheme, so we get all these crypto operations highlighted, just to make it easier to find. And this is indeed the crypto function, and this is generally what we're looking for. So I'm going to walk through this and show what all the functions are, just for the first time, but we're not going to normally do it because you don't really need to. All you're looking for is a function that is going to go through a loop. And basically this first loop is finding the length of the cipher or the plaintext string. Once we have that length, we're going to allocate memory, and then we're going to decrypt it, I think, into the new memory. So that's going to be the standard of how the standard function looks and how you want to recognize it. So let's go into this first function and just label it up. And again, we'll go into the subfunction. We see this is just a heap alloc. So L to label, call this heap alloc, alt left to get back. And we see we allocate memory. And then we move that into EDI and push it on the stack as an argument to this function. So we double click this. And we see here we're just in a simple loop. We're dereferencing a buffer 1 byte and moving that into another buffer, the param, looks like the param1. So this is literally just a string copy. We know it's a string copy because we're going from one parameter into the other, and we're doing it until param2 is, well, it's not equal to 0, so null terminated string. So we'll hit and L to here. We'll call this string copy into new heap, alt left, and then we will hit so this whole thing, we allocate here, string copy into new heap. So we'll call this whole function string copy into new heap, and alt left to get back. So we string copy new heap, we come through, determine the length of our ciphertext, allocate new memory, and then we decrypt the ciphertext string. So what we need to figure out next is, let's start with the key address. The easiest way to find the key is going to have a hard-coded length, and you're going to basically do the modulus of the length to decrypt the string. So it's just a simple XOR, it's just a rolling XOR. So we can see, so we're looking for a modulus value in this decryption loop. So we see an AND here with EDX of 3F. That's doing a mod of hex 40 because it basically goes 0 through 3F. So that's a mod 40. And then EDX is our modulus. That's offset or indexed into this data 410120. So that means this is our key variable. It's not going to be the ciphertext because you're not going to have a hard-coded length of the ciphertext. As we saw some from the decrypted indexes, they occur at odd numbers, so it wouldn't be padded out to 40 like this would here. So that's pretty simple to find the key. Just look for the crypto loop, and then look for the modulus value, and where the modulus gets used as an index. So let's go back, and we see our key is 410120. Our ciphertext is just as easy to find. So if this is the key value that goes in DL, we're XORing the key value with a ciphertext, because this has a global variable that's going to be the ciphertext, and so 40 Bravo 930, and you can see we can double click this, and we go to it. So here's the ciphertext in there. Alright, so let's go back. So it's going to be 4 Bravo 930, and we see we have 4 Bravo 930. The last thing we need is the ciphertext length. The ciphertext length we can get from this bottom crypto function, but it's actually easier to get it from the function at the top that gets the length. So if we look here, we're inside our loop trying to identify the length of the cipher string. And so we look for the exit condition. So we can see here, we're going to be inside of a loop increment EX until we reach ECX times. If we move over, we see ECX here is 36F4. So if we go back to our script, we see I have 36F5. We could use 36F4. Either one will work. If we look at this case, it's the reason we use 36F5 is because it was bigger. Because the string copy new heap is 4 Bravo 930. If we look back at our details, that was our ciphertext. So we're copying our ciphertext into new heap memory, and we're saying the size is 36F5. So this is just a little bit of discrepancy in how it gets programmed. And it's probably just take into account whether you start your indexing at 0 or 1 or exactly the copy. So instead of going into details to try to figure out exactly what the length, I just picked a bigger one because in this case it just tells you how far to decrypt the cipher block. So you don't want to be short, but if you're 1 byte too long, it's not going to make a difference. So in this case, we use 36F5. And that's all we needed to fill out the variables for this first push. The other thing we want to look for, and this only matters for variance because obviously for this F5 FF sample, these values are all going to be filled out correctly. But if we scroll down to the first function, the decrypt string function, we want to look for, we can see we're getting our key byte and then our ciphertext blank byte, and we're just simply XORing them together. But when we get the key byte, we're going to have to get the mod value, so mod 40. For variations, you will have to change this, and this will change through different variations. So if we go back to the key, so this is pretty simple, because as we basically find the mod value to look for the key, and we just see the mod value here. Just be careful that the mod value is not 3F. When you AND something with 3F, that means it goes 0 up through 3F, so you basically have 40 as a mod of 40 hex. Alright, so that covers the first function that has the arguments pushed on the stack. Let's do the same thing where the argument is passed via register. So we're going to go back to the flat view. And instead of searching for the push, I'm going to search for the move. And again, do search all. I'm going to sort by preview just to make it easier to find. And I'm just going to scroll through looking for the numbers that make sense. So this 1 Delta 8 Bravo looks like a great sample. And you see in this case, it's not moved into register right before functioning. So even though that number looks great, it turns out to be a false positive. This 1122 could be it. So let's check that one. And so this one we move into ESI, but then we have a jump. So that doesn't look like a good candidate. So let's keep on going, look for a better one. This 1 echo 3 echo looks good because that's really big. It's an odd number. And we see that one is true. We moved it into a register, and then we can see our script decrypted it. So this is 4 Bravo 6 406 5 Bravo 7. Sorry, and we can see here 406 5 Bravo 7. So I'll to label and call this crypto decrypt strings 0, and then we'll double click it just to verify. Go back to the graph view, and we see just like before, we copy the key variable into new heap memory. So let's go ahead and do the same steps as before. So we had the first loop that identifies the length of the ciphertext, and then we had the crypto block down the bottom. So first we're going to look for our modulus value. So we see the AND with EBX of 3F. So EBX goes into here, which means that 410120 is our ciphertext. And we see our ciphertext here is 410120. And I forgot to mention, so we saw the parameter that's got passed in the register was EAX, so you need to specify that. That's for our ciphertext. This BL is the key byte, and we see EDX is our index. That makes ESI our key block. So we can see here ESI comes from 410634. If we come over to here, that's not the value we have for ciphertext. And you have to be careful with this. So if we select this value and scroll up, this is getting these copied from the 4 Bravo 930 into new heap and then stored, so it's dereferencing another pointer. So you have to be careful. Again, the functions where you push it on the stack, you tend not to use this, but the functions you move to the register, you tend to use it. So it could change in variations, so you always need to backtrack it just to make sure it's the actual global variable and not a dereference pointer like this one. And then our ciphertext length, just like before, we can use this 36F5 or the 36F4 if you really want to. It won't make a difference. So now we identified all the variables for this second one. And if you were analyzing this file and you came across more functions that looked like the decryption function that didn't have identified, you could just overwrite if it's one of these parameters, either if it's pushed on the stack or moved in the register, and then rerun the script. And we're going to do that with the second example. So I already had the second example done, so I'm going to go ahead and open that up. This one is for the hash delta alpha 05722F, it looks like. And so we're not going to run this one. We're going to start this one assuming we don't know what the answers are. So let me go ahead and close this down. Alright, so we have our sample 2. So let's go ahead and do our Control-Shift-E. So we need to find our variables, our target functions. So we're going to do a push *0x1, and we're going to search in the instruction mnemonics and the operands and hit search all. Sort by preview, and then I'm just going to scroll down until I find a good value. 1F4 in theory could be okay, but it's used multiple times, so that didn't look good. 1 delta 6 is an option, but it's easier when they're bigger, so let's see if we have a bigger number. So 1 6 Charlie 4, that looks like a good one. And this is pushed onto register, so that one with the multiple arguments actually didn't look like the right one. Let's keep going. So the 1410 could be an option, but because it's an even number, I want to find one with an odd number, because this tends to work out more often. I'm going to keep scrolling through. These are all even numbers. But I didn't see a great one there, so let me resort the other way. And let me look through this one more time. If not, in fact, I didn't see a great one, so let's just go to the 2s. So we're going to do the push 0x2, and then we'll search all. And I'll sort by preview. And just scrolling through until I find a good number. So these are all even numbers. Yeah, these are even or repeated numbers. They don't look like good options. 2 6 delta looks like a good one to test out. And you see that's pushed and goes into a function. So let's double click this function and see what it looks like. Open by graph view. I go into the sub function and I scroll through. I see a loop with a mod value here and a crypto loop at here. So this looks like a good option. So I'm going to hit Alt left. And so this one, we see 1109 alpha, and that is the function we're at, 1109 alpha. Auto label and call this crypto decrypt strings. Alright, so I'm not going to bother labeling the functions, but I know that this first loop is finding my length, then I'm allocating memory, and then I'm doing my decryption. So let's find the ciphertext first. So we need to find the mod value. So I see a div here, so that means that EDX will be the modulus value. EDX here, so we're indexing off of EAX, which comes from param3. I select that and scroll up, just make sure it's not overwritten anywhere. And so we have to be careful. This is param3, but this is fast call colon convention. So we see param3 is the first stack variable. So Alt left to get back. And the first stack variable is that 1001 delta 050. And we see that we have here 1001 delta 050. So now let's find the ciphertext. So that was the key. So if EDX, if this AL is our key byte, we're XORing that with the cipher block. And then it looks like the cipher block looks like it can come from this local 8. So we select local 8. We scroll up and we see where local 8 gets set from. Local 8 comes from ECX. So Alt left to get back. And ECX is that 1001 delta O Bravo 0. And that's what we have here, 1001 delta O Bravo 0. Now we just need the length. So let's scroll through. Remember, the length is usually easier to get from this first loop that finds the length. So we increment our counter here, and we compare that to ECX. ECX comes from EAX, and EAX comes from EDX. So Alt left to get back, and EDX is 4F3. So that's what we have here, 4F3. Now let's find the function we're passed by the register. So instead of the push, we're going to go do the move, and we'll start back searching at ones. And you can see here they find more than 500 matches. And that's why we started with a number, because get too many, it's just hard to look through, get too many false positives. So let's scroll through here, just looking for good numbers, big numbers that are kind of odd numbers. So this 11 echo could be an option, but that's not moved in the register right before function. 15 bravo is a possibility. Again, that's not moved to the register right before function. We keep scrolling through. And I didn't see a good number there. And remember, they had more than 500 hits, so it might just not show up in the search. It's easier just to update this number to 2 rather than changing the Ghidra options that show more than 500 hits. So this 2-3 delta, that's an odd number. Let's check that one. But again, not moved and register right before function, so that didn't look like it. 2 alpha 7 looks like a possibility, and that's moved into a register right before function. Let's double click the function, and we see the same format as before. So this one I can hit auto label and call this crypto decrypt strings 0. So this address is the 95 alpha delta. So you can see if we come back to here, we have the 1095 alpha delta. Our parameter passed through is ECX. And let's find the key. Double click it, and this time the key is different. So again, we come through here, we have the first loop, find the length, allocate memory, and then the second crypto loop. So we see our mod value with this div. So we're going to EDX is our mod value. That means it comes from ECX. ECX comes from param3. Scroll up to make sure param3 is not overwritten anywhere. And we see again param3 is the first stack variable because it's a fast call calling convention. So alt left to get back. And ECX is 1001 delta 5 alpha 8. So is 1001 delta 5 alpha 8. Sorry, let me look at that. Let me check that again. So we have our div, our EDX, this is going to be the key. This comes out of ECX and param3. Yep, param3. So it looks like I had a typo in my script. Oh, sorry. Param3 first argument pushed on top of the stack. So I saw that wrong. So we see the first push here is 1001 echo 3 F8. So you can see we have here 1001 echo 3 F8. So you gotta be careful of that fast calling convention so you grab the right argument. And now let's find these ciphertexts. So if ECX, so if AL is our key byte, we're XORing that. We see EDI is our loop index. That means EDX is our key byte. We do that for local 8. And we scroll up, make sure, and we see local 8 comes from ECX. Alt left to get back. And ECX is 1001 delta 5 alpha 8. That's what we misread before. So 1001 delta 5 alpha 8. And now let's check this length. So remember, the length is virtually always easier to get from this first loop. And here we have the increment and loop counter. We loop that, increment that, and compare it to EBX. We scroll up, and we see EBX gets set from EDX. So alt left to get back, and that's echo for Charlie. So echo for Charlie here. And you notice our key, our ciphertext, and our length are different between the push function and the register function. The one other thing we need to verify in here is the key modulus length. Now I had this updated, but this is something you'd have to change from the original, because here our mod, as we're doing modding by param5. Let's scroll up, see where param5 gets set from, and we see we're moving in hex 5 alpha. So in this case, because it's a div by 5 alpha, the actual mod value is 5 alpha. So if we scroll down to the first function, you can see here I updated my modulus value with 5 alpha, but if we look back at the original, it would have been, I think it was 4.0. Yep, it would have been 4.0. So if you didn't update that, then your crypto will not work correctly. So that's all you need to update. You need to update this modulus value and the variables at the top. And now that it's updated, let's go ahead and run this to verify. Hit our play button for the script manager, AGDC services, and this one is the Delta Alpha 05 script, and I'll hit play. Alright, let's go up to the top here and just verify this worked. So Alt left to get back, and let's find some of these cross references. Control Shift F, and we'll just check the first one. And we see this decrypted to HTTPS. We'll just check a couple just to verify they all look like they work. And you can see here ASW, HookX, and HookA. So looks like everything worked okay. We can see at the bottom it couldn't only resolve 2. So we hit G to go, 1000 Echo 1 Delta 5. And we see couldn't find it because it looks like it's pushed potentially as a EDI, which would probably be passed in. And so we'd have to be able to track that down to see where it is. Or this one might have been the register from Param, probably the register for Param 3. And we had the same cipher block, or plaintext block up here. Now when you have, in this script, because we have 2 different ciphertext blocks, you can see the addresses are different. Inside my script, so you can see if we scroll up, if you keep scrolling, let's go up until the offset, near the zeros. Actually, yeah. So you can see this starts off, we had the 5-9, keeps going up, and then goes through the 4s. And then at 4 Echo Charlie, it resets at 0. That's the second decryption block. So I print out both decryption blocks. So you have to be careful when you're looking for your index if you need to resolve these manually. Make sure, realize that you're going to print out both encryption blocks if they're different. So that way, if you're looking at this first part and you don't see the index, you may need to go down to the second decryption block. So there's one more thing I want to show, because as I mentioned, these scripts can have more than one function that perform the decryption with different ciphertext and keys. So let's do one more search. In fact, I can close down this one. So I'm going to do the move. I'm going to go do the 4s because this one I've already analyzed. Do the search all. And we're going to go down to 496. That looks like a good number. We can see we're moving 496 into this new function. And we double click it. Let's check the graph view. And we see that looks like just like before. So that means Alt left. That means this function is a crypto function. And it's just had a different parameter or a different information than the previous. So I'm going to go ahead and update the script and we'll run it for this one too. So 1080. So this one is moved via register, so it looks like ECX. So we'll just change this bottom one. So 0x 1080. It's the register's ECX, so that we can stay the same. And then let's find the key bytes. And let's go ahead and label this. Crypto decrypt strings 1. I'll double click it. Go into the graph view. Just scroll to the bottom here. And I see my mod. So EDX comes from ECX. Comes from parameter 3. And then parameter 3 is the first stack variable, Alt left. And we see the first stack variable, 1001 delta 050. So 0x 1001 delta 050. And then let's go ahead and delete these so we don't get confused. And let's look for the ciphertext now. Double click it. The ciphertext, if this byte was the key byte, then we're XORing that with the ciphertext. EDI is a counter, so EDX is our buffer, and that comes from local 8. Scroll up, and local 8 comes from ECX. So Alt left, and ECX is 1001 delta O Bravo 0. So 1001 delta O Bravo 0. And then our length We'll double click it one last time. Again, we'll go for this first loop because it's just generally easier. And it is comparing the loop exit condition to EBX. And EBX comes from EDX, so alt left. And EDX is 4F3. 4F3. Now you notice here, if we double click these values, they're repeated from the first configuration block. So that means we had two configuration blocks. For the first configuration block, we have the function that takes the arguments via the stack, and a function that takes the arguments via the register. And then we have a second configuration block that takes the arguments via the register. I haven't fully analyzed this. Maybe it has another decryption function that takes the arguments via the register for the second information too. But this just goes to show you that when you find these, you may come across more than one. And if you do, so I'm going to go ahead and save the script. The easiest way is just to update the script this way. And then let me hit alt left to get back to the cross references. Instead of making this super generic, it's just very easy. I find these variables. If I come across a new one, I just overwrite it and I will run it again. So I go to script manager. I'm going to go ahead and run this script. And then we see it printed out our decryption string, our plaintext string on that function. This case, it was able to resolve everything. And then we see the decryption blocks here. It goes from 0. And because the same block only has 0 through 4, so it only prints it out once. So you can see how many strings Qbot uses. So by being able to quickly decrypt these, you can target on the locations of interest. You can just scan through it, pull indicators out that way. It can also help you identify, verify it is Qbot. And just by the strings, you might be able to determine the variation in Qbot. Just be a little bit careful with that because the variations I've seen, I don't analyze a lot of Qbot. I've seen them use the same configurations from previous variations with strings and then just basically use code reuse. They didn't actually use the decrypted strings. So realize that just because you see the string doesn't mean it'll be used inside the malware. It could just be code reuse from a previous variation. But just remember, the script is in my GitHub page. It's linked in the video description. And so you can see how easy it is to both run it and to update it for variations in Qbot. And all the Qbots I've seen have just used a simple XOR decryption. So you shouldn't have any problem updating it just as we did for the second variation. So I hope you enjoyed the topic today. If you did, please like the video below and subscribe to my channel so you get notified when new videos come out. If you want more reverse engineering tips, follow me on Twitter. If you're interested in structured training, check out my website for the malware analysis class that I offer. Until next time, keep on practicing and try to learn something new every day.